Good morning. Thanks very much. I was actually worried that there was going to be nobody here at this talk, and then I saw the last poor gentleman getting up and talking 45 minutes ago, and it was packed as well. So congratulations for all of you, especially West Coast people who are out here early in the morning. Oh, with the coffee. Fantastic. All right, let me get started. I wanted to talk to you all once my slides come up. Now we know it's morning. It's not Monday. No worries. We'll get started anyway. So Akamai Technologies is one of those companies that people at an AWS show usually ask why we're here. Some of you may know the company. We've been a content delivery network for the last 20 years, but we've been gradually adding security services since the year 2002. In 2002, we were approached by the NSA when there was going to be an attack on the US government infrastructure, and were asked if we could actually put our network in front of their critical infrastructure so that we could absorb, at the time, what was considered to be one of potentially the largest DDoS attacks ever seen. Now, since then, for the last 20 years, we've been building out adaptive security controls so that we can manage threats and mitigate threats for people's critical infrastructure, and that's what I wanted to actually talk to you guys about today. When you migrate to AWS, one of the things that we end up talking to a lot of our enterprise customers about is exactly what it entails. What does it mean to adopt the cloud? What kind of a journey is it? How long is it going to take me to move my critical applications to a cloud infrastructure? And basically, what are the things that I don't know that you can advise me about as a partner so that we can keep our applications secure? Now, in the realm of some of this stuff you can't make up. In the realm of developer operations, one of the challenges that we see is, as a content delivery network provider historically, we've been dealing with infrastructure and operations folks. One of the challenges with application development, CI/CD pipelines, and agile deployments is that infrastructure folks are really having a hard time understanding the context of an application and why developers need to move so quickly. And so they try to put all of these sort of arcane protection measures in place so that they can stop developers basically from hurting themselves. So I'll give you a little bit of history. 20 years ago, I was an database administrator, and one of our jobs as DBAs was to help XML developers save themselves from making horrible mistakes online. It was 1998. People were getting excited about throwing all sorts of applications out on the internet. XML data islands were a thing that people got really excited about. And what they asked the DBAs to do was basically to lock down the environment enough so that developers couldn't deploy an application that would embarrass the business. We had all the power. We were able to say no to people when they were trying to do silly things with code. Things have shifted materially, and now what we find is infrastructure and operations folks really are required to enable developers to deploy applications the way that they need to support the business. I'm going to be at about slide 6 by the time we get slides. That's my guess. So let's talk about what Akamai actually does for applications. As people move to the cloud, they start to understand that different clouds provide different advantages for users. AWS happens to have the most robust tool set of all of the cloud providers out there, and what we find is many application developers come to us to help make a case for why AWS and not Azure, why not Google Cloud Platform, why not just keep everything on-prem? Especially when we deal with our public sector customers and financial services, the advantages of having such a robust partner ecosystem and such a huge set of tools that they can bring to bear to develop robust applications are one of the main reasons that we try to present to our customers to try to help make that case. Sorry, I'm just watching what's going on here. So as we migrate our customers to the cloud, one of the things that Akamai is attempting to do is to explain to them where the edge fits relative to their cloud platform, or relative to their cloud infrastructure. If we think about the edge as a topology, people move from a core data center to the cloud. From there, they're trying to reach digital touchpoints. Now, one of the challenges that you have going from the cloud to a digital touchpoint was actually evidenced yesterday. Is anybody aware of the BGP route errors that were occurring yesterday? So it affected quite a lot of very large websites. One of the challenges with trying to ensure consistent delivery is making sure that you can get as close to your end users as possible, which means that you need to penetrate as many of the ISP platforms, as many of the telco networks as you can, so that you eliminate peering points that can ultimately lead to challenges like we saw yesterday. Akamai, having built a CDN over the last 20 years, has actually overcome a lot of those routing challenges and have built our own backbone to ensure consistent, secure delivery for our customers. What's interesting is because of that infrastructure, we've actually amassed a wealth of insight that we've been able to bring to bear for the last 15 years to help protect companies from emerging security threats. So what do I mean by that? Well, let's take a couple of examples. If you think about last year, Memcache UDP reflection was something that took a lot of developers offline for a while because the attackers targeted GitHub, one of the most popular code repositories out there, and the amount of traffic that was reflected at the GitHub infrastructure was something that their ISP-delivered DDoS protection platform couldn't handle. Now, when you think about a DDoS protection service, many people think all you really need is enough capacity to scale with the size of the attack. The challenge with UDP reflection isn't that it's a complex threat vector to protect against. Those machines never should have been exposed to the internet. UDP reflection is something that is a very easy rule to deploy. It's an easy ACL that most people put in place. The challenge becomes when you have the volume of traffic that can be reflected, you need to have enough bandwidth, enough infrastructure to actually manage that traffic. And the ISPs, as part of their contract with their users, don't actually guarantee that they'll be able to absorb any size attack. There's a certain threshold at which they'll start to black hole traffic. Our friends at Thousand Eyes were able to actually produce some pretty interesting visualizations where you can see the amount of traffic being reflected at GitHub climbing and climbing and climbing until finally they were effectively down. Their infrastructure never went down. Servers were never offline. The code repositories were available the entire time. The problem was it was impossible for any traffic to actually reach those data centers, to reach their code repositories. And so effectively, nobody could reach that provider until they routed onto Akamai's DDoS protection solution, because we have enough capacity and enough network management capability to actually route those, to actually take the traffic and route it around the GitHub servers and to some locations where Akamai can actually start throttling all of that traffic. Now let me get back to the actual touch point. When we go from the core to a touch point, and we talk about the challenges that you have moving from the cloud through the edge, Akamai inhabits this space. And what we mean is if you think about the different edges, there's a network edge. This is when you talk about, for example, zero trust solutions and networking protection for enterprise applications. That's your network edge. That's usually what you use WAN solutions for. If you think about the internet edge, that's where most CDN technologies are deployed, and then you have a device edge. Now inside of that, if you talk to different people, there's a heavy edge, there's a light edge. But when we talk about the edge, what we're talking about is that area, some people call it the middle and the last mile, but that effectively goes from your cloud data center to wherever people are consuming your services. Where the edge helps is by helping you deploy a consistent set of security controls. One of the challenges that we find when people move to the cloud is that they're forced to maintain a hybrid infrastructure for quite some time. You have some of your critical capabilities on-prem, or you're forced to balance across a number of different cloud providers. One of the biggest conversations that we tend to have with customers as they begin their journey to the cloud is how they should be leveraging container technology, and if that really provides them with the autonomy and the flexibility to deploy applications to any cloud provider platform that they choose based on pricing, based on availability, or any regional strengths that they might realize. The fact of the matter is, it's not as ubiquitously portable as most of you developers know, as most executives would hope. But what the edge helps provide is enough time for application developers to focus on the unique implementation details and the unique strengths of each cloud platform while maintaining consistent security. So what Akamai does is, at the edge, provide a set of layered defenses, defense in depth effectively for applications and APIs. We start with authoritative DNS protections. That's a form of DDoS protection solution. We also manage infrastructure protection, which for AWS, for example, isn't really relevant, but for any of your on-prem data centers certainly is. AWS maintains a shared responsibility model, as most of you know, so they're responsible for maintaining the security of their own infrastructure. You just secure the apps that run on top of it. And so for that, Akamai's developed a series of capabilities that we apply however you decide to consume them. We have a web application firewall, client IP reputation, and bot management services that can all be deployed and applied automatically. So we've got automated rule protection in our WAF that protects against 8 major categories of threats. We've got client IP reputation scoring, which takes advantage of the fact that we have the world's largest globally deployed CDN network and all of the visibility from the 2 trillion DNS resolutions, 1.3 billion client device interactions that we see every day to help provide you with enough intelligence to build in automated rules that won't result in a lot of false positives. And then we provide very simple tuning, either via web interface or scripting, so that as you deploy new applications and new business logic, it's very seamless for developers to apply the specific rules that they need to ensure that we're not disrupting the business with the security controls. So let's talk to you a little bit about how that works. This could be a typical topology for deploying your application in an AWS cloud. You've got your different regional availability zones. You've got auto-scaling groups deployed. Within that, you may have any number of applications. We're specifically not diving into the types of containers you might use and how you would use different services on AWS, because at the end of the day, from our perspective, we're looking at AWS like any other application infrastructure that you need and focusing more on the application traffic that we have to secure. Now, as you use the edge, I hit too many times? That one just doesn't want to build. The first thing that we look at is how we're actually going to be protecting your applications from attacks. Now, the applications themselves can be web applications, they can be API-enabled applications, they can just be individual microservices that you need to scale to make other distributed applications work. From a web application firewall perspective, what Akamai is looking for is what are the different threat vectors that we need to start protecting against, and how do you want us to secure them? How many individual policies do you need? Do you want automated rule protections? Do you want to deploy all custom configurations? But then from there, we look at increasingly the difference between web traffic and API traffic. One of the more recent vectors that we see most of our customers falling victim to if they don't have a good understanding of the applications they should be protecting is the proliferation of APIs that developers are producing to power microservice architectures, to power data as a service, and they're leaving those API endpoints unprotected. We start with an API gateway. We like to make sure that you've applied some form of authentication and authorization for the API, so it's effectively not like leaving the front door to your house open. But then we want to apply positive security. Positive security is something that's really challenging for a security group to apply because typically they don't have a good understanding of your application. When we talk to a chief information security officer and ask of all the constituents in the business, what's the group that keeps them awake at night, that really concerns them because they don't understand the fundamentals of what drives them every day, it's the front-end application development team. Because they're constantly being asked to serve the business with new workflows, with new ways of enabling revenue for the business, but the security team doesn't have any context on that. And when you apply rules, for example, for SQL injection protection, cross-site scripting, remote file inclusion, et cetera, increasingly you're disrupting the business because you're basically stopping them from architecting the sort of workflows that they require. In a microservice architecture is one example. Depending on how you deploy your infrastructure, every single call could in fact look like a cross-site scripting vulnerability. And so how do you start to protect against that? We start by adding API protection into the purview of the Chief Information Security Officer's group. And so what we allow at Akamai is the import of a Swagger or a RAML file and versioning of the APIs so that everybody that's managing a web application firewall has some context on the API traffic itself. We give visibility to understand who's accessing that API. If we start seeing any sort of anomalies in the access patterns, for example, we see people from a given region varying their IP addresses or varying their user agent strings more than we actually see individualized requests through the application stack itself. And then we can see that somebody's starting to target the API, or at least there's a high degree of confidence that we have to alert the business that something looks amiss with the way people are accessing the API. But with a mix of the API gateway and the web application firewall, our goal is to ensure that positive security can be applied to what was historically a more passive security model with WAFs. We then start looking at how we actually start blocking attackers based on the difference between human interaction and bot interaction. So there's a step-up sort of management that we try to apply at Akamai. The first one is just looking at normal API and normal application usage patterns across the business. So we've got visibility that we provide and that we actually integrate with AWS through SIM integration and CloudWatch, so that you can see typical access patterns for your app. From there, we start to look for anomalies in varying IP addresses, varying user agent strings, varying locations and times of day of access, and provide you with basically a scoring mechanism, 1 to 10, to understand client reputation. From there, we start looking at access patterns that are uniquely or distinctly not human. They're either too ordered or they're too random. But either way, we're starting to collect signals from application access over the web, application access over mobile devices, and increasingly API access patterns for services to try to discern the difference between human and autonomous traffic so that we can, again, warn the business. Now, that's critical when we look at the rise of things like credential stuffing and credential abuse. Many of our customers, especially in Asia, really don't have a good handle on the challenges from credential abuse and credential stuffing. The challenge becomes as you deploy additional services and you don't really know what sort of an access pattern to expect, the intelligence to start to discern the difference between human and bot interaction is something where you actually need a healthy amount of visibility and history to be able to apply rules for. And so one of the big challenges that we see companies dealing with when they migrate to AWS initially is, what should I be expecting for my access patterns? What does a normal set of logs that I'm going to be processing through my CloudWatch system actually show me? And we've been bringing the intelligence from all of our distributed applications to bear to start to highlight, look, these are access patterns that we've seen that were preceding an attack on a major bank for anybody in the banking sector. And we provide, for example, client reputation access based on industry specificity and regional specificity. All of that, as we were saying here, can be integrated with the SIM and actually pushed into your log management system on AWS. But I think the bigger thing that we always try to deal with here is the consistency of security controls. The biggest challenge that a developer will have trying to start a conversation with a security group is going to be how to actually understand what consistent security policies should mean to them. Because every developer is going to be focused on their microservice, their application, and ultimately how they're gold. They're not gold for a consistent application security system across the business. They're actually gold on making sure that there's adoption and use of their app. So when we look at the way that Akamai is looking to apply consistent security, the very first thing that we consider is, what are some of the major goals for the business? If it's maintaining security and compliance so that you can operate in a region, great. If it's data locality because you have to move into a region that has very stringent data control and data access rules, then we want to apply those controls consistently across applications as well. Where it gets to be more challenging is when you start looking at all of the proliferation of apps that developers are deploying across AWS. And this is really where securing applications using an AWS firewall starts to become really challenging. Not impossible by any stretch of the imagination, but even with partner rule sets like Fortinet rules, F5 rules, and Imperva rules, what have you, you can get a measure of security on top of your applications that will protect you from some of the more standard vulnerabilities. The OWASP top 10, some of the zero-day attacks that were 0 days, 6 to 12 months in the past. But the challenge becomes actually applying consistent security to each of your individualized applications with the nuances that are required to enable the business to move forward, or that can basically avoid false positives. What we see most of our customers starting to apply is they're using virtual private cloud technology to try to avoid access directly to the application infrastructure that they're not anticipating. But that in and of itself is not going to be enough to protect the business against some of the challenges for some of the more recent attack vectors that we see. So when we look at automated attack groups, the challenge that we're addressing for developers is the ability to not have to consider all of the different threat vectors that are emerging across the internet. You don't have to worry about the latest attack pattern, for example, the mage card attacks, where you have third-party JavaScript that starts to compromise your application environment. Or we start thinking about the ways in which attackers are starting to exploit, for example, API endpoints using stolen credentials to try to gain access to an application backend infrastructure. What we're trying to apply here is flexibility for every business unit to be able to gain the benefit of autonomous rules and then specificity and customization so that they can create the specific business logic that they need. The goal is ultimately to drive to consistent security policies and to make sure that one security team can manage the policies for the enterprise. The developers have the flexibility to control access to the APIs and secure the APIs themselves. And then fraud teams can start to get much more involved as they get signals from all the application access, all the API access, to start really understanding the threats from bots, from credential abuse, from credential stuffing, and increasingly what we're seeing is some of the emerging threat vectors with APIs being basically the weak link in the chain for a lot of our customers' apps. Now, when we talk about protecting everything everywhere, one of the issues that starts to come up in our architectural discussions is really, where do I want to be applying my security controls? Can I have portability for my security rules across a myriad of cloud platforms, back-end infrastructures, and as, for example, companies acquire either new technologies or other companies and an M&A activity ensues, how do we merge all of our back-end infrastructure together while still maintaining a level of security that we're comfortable with? Or put another way, how do we basically apply risk tolerance across the enterprise? When we look at protecting everything everywhere with Akamai, why can't I click this button once? We're going to try it with the button. The first thing that we want to look at is how you apply consistent security policy. Consistent security requires you to have purview that goes across all your different applications and the infrastructure that you're trying to manage. Now, we talked about AWS having a shared responsibility model and being responsible for its own infrastructure security. So at least as developers and infrastructure teams who are managing apps on AWS, you don't have to worry about securing the AWS server stack itself. But you do have to worry about that if you've got a hybrid environment. And you have to especially be concerned with things like load balancing. When you're going to have, for example, service calls coming from different back-end infrastructures, you have to think about the challenges from migrations or evolutions of applications as increasingly the apps will move from the corporate data center to the AWS cloud. You're going to want to have a policy for applying security while the application developers maintain autonomy for deploying their apps. When we look at the challenges of increasingly employing third-party contractors, developers who might move to another business, access is one of the other challenges that we see. It's not a threat vector from an external threat actor. It's a threat vector from potentially unfettered access to your back-end infrastructure, because managing things like VPN rules, access controls to back-end infrastructure, or access to applications themselves can be something that's really challenging, especially if you have high turnover in the sorts of consultants that are accessing your applications or building your applications. And so what we find a lot of shops asking us to do is to help them with their VPN management or migration from the VPN. And Akamai has started to increasingly build out enterprise security solutions that will help to eliminate VPN access and actually start to secure the applications as the perimeters themselves. So the perimeter, being the corporate application of the corporate network, is something that, if you pay attention to what's underneath all the zero trust messaging, is becoming an increasingly trite concept. But what we focus on instead is, how can we harden every application? How can we make sure that the apps themselves are only visible to people that should see them, that are only accessible to the people who should have access to those applications themselves, and to make sure that any of the access that they have is only to the sorts of application calls, to the function calls, or the APIs that they should actually have access to. And so we've developed enterprise application access technology that allows you to look at every individual application and the access to it versus the access to the corporate perimeter or the corporate network. Now, the intelligence that we've amassed across the Akamai platform is what really helps all of this stand apart. The rule sets that we've built up are built from all of the visibility from applications running globally across the platform. It's shared intelligence between internet-facing applications and corporate apps, where we can start to look at things like, what are the IP addresses, user agent strings, access patterns, and access types that are pervaded by application threat actors from the internet, and also people who are trying to pervade or penetrate the enterprise using phishing, malware, or ransomware schemes. And one of the interesting things that we're finding with our threat research is that a lot of the folks who are starting to, who have been kicking off these DDoS attacks that are threatening some of our customers are the same people, or the same at least IP addresses, the same CIDR blocks, the same user agent string pairs that are also trying to perpetrate phishing schemes. And we're starting to look at this because with MageCart, we started to understand that there's a real challenge with the way that developers are assembling applications and the way that they're trying to secure apps when the application is assembled in the client. So if you think about the way that you build an application and some of the threats. For years, we've been protecting applications from DDoS. We've been protecting applications from internet-born threat actors in the form of SQL injection, command injection, et cetera. We look at bot attacks as an emerging vector about 3 to 5 years ago. Then we started looking really at secure access or enterprise security and zero trust. But now, the new sort of weak link in the chain is content that's assembled in the browser for every user who's trying to use a web application. MageCart was one example of a vulnerability where web application firewall technology couldn't possibly protect you because the threat wasn't there when the application was delivered. It was downloaded by the browser itself. When we look at some of these emerging threats now, you need security that's going to extend into the client and who's going to be able to understand the signals that are being picked up on the client itself that were never present in the back-end system. And so we can enable developers to do testing in sandbox environments, to run what-if scenarios on the firewall rules with the sort of application access patterns that they can anticipate. What we are struggling to do today, and what a lot of folks in the security industry are investigating moving forward, is how do we actually take that intelligence and apply it when the threats are being downloaded in the client itself? Because the end users, from their perspective, are just using the application the way that it was designed. But the threat actors are realizing that if I can compromise a third party that gets downloaded, and this happened a few weeks back and was actually outed where 1,200 different applications were compromised because one single revenue protection company had its code infiltrated by a threat actor, and that was used across 1,200 different application providers out there, all of whom then compromised their end users, or at least potentially did, because their code was basically being used to scrape individuals' information and send it back to an origin that wasn't actually the application owner itself. And so the new threat that we're trying to protect against with the visibility that we can apply over all of your cloud infrastructure, your corporate infrastructure, is this ability now to take signals intelligence and apply it out to the edge, but even further to the touch point with the client. And that's what we'd like to engage with you on today is Akamai's over right there at booth 327. We'd like to talk to you about cracking the code at the booth. We'd like to talk to you about your application security controls and how we can apply consistent security for you in AWS to allow you as developers to really focus on building the next-gen apps of the future. So with that, apologies for the rocky start here, but just about on time. Thanks for your time, and we look forward to seeing you at the booth.